Hello everyone. Welcome to the platform of Unacademy, India's largest online learning platform. I welcome you all in this platform, and we are going to see some of the new aspects of metal forming. Okay. So once again, I welcome you all. And before starting the session, I would like to give a brief introduction about myself. My name is Vidyapati Kumar, and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of various research papers publication of national and international journal of repute. You can follow me at unacademy.com @ v.kesar, where currently I'm teaching the strength of material full course. So, hello Battle Wing, hello. Chaliye. So basically in this session what we are going to start, we are going to see the rolling operation. In yesterday's session we have started the metal forming, and we have seen that how metal forming is important for gate point of view, and most importantly what are the topics that we have to study in the metal forming. Concerning that, we have also categorized that based upon the metal forming, there is a two kinds of loads, that is either a bulk loading is there or the light loading is there, and rolling operation is categorized in the bulk loading. So definitely whenever we are giving a bulk load, that is a huge amount of load is given, in this rolling operation comes over. So we are going to see very different aspects of the rolling, as well as we are also going to, if time permits, definitely we are going to start the mechanics of the rolling also, so that our concept regarding this rolling operations would be very much clear. Okay. So if you haven't downloaded the Unacademy Learning app, download the Unacademy Learning app. Go in the Play Store, search about this Unacademy Learning app and download it. As sign in there, and here I am teaching the free classes. So what is the free classes? It is known as special classes. Special class, I am teaching the strength of material full course. So for GATE 2021. So definitely that would be very much helpful. Full course is there here, as well as there is another aspect that is known as plus subscription. So when you will be paying some amount of money and then taking the subscription, so after subscribing you will be getting the plus subscription. So it is paid, but this section is completely free. So definitely you can check about these things, and I am teaching the strength of material full course, so definitely you can go and getting benefited there. So what are the benefits of the app? You will be getting the daily live classes. Courses are very much structured in nature. Tests and quizzes you will be giving, and unlimited access of the course content materials are also there. If you are moving over the plus subscription, there is a complete coverage of the syllabus would be there. So here the complete coverage of the syllabus would be there. Dedicated doubt clearing sessions would be there. So doubt clearing sessions would be there. So here the doubt clearing sessions would also be there, as well as daily live classes are there, that you will be getting opportunity to interact with the educator, and definitely whenever you will be facing any kind of problem, definitely you can resolve your issues at the same time. Courses are very much structured in nature. Tests and quizzes you can give, unlimited access to the course content materials, PDFs of the classes would be given to you. Another subscription is known as iconic subscription. In this subscription you will be getting all the benefits of the plus, as well as you will choose your choice of educator to be your personal coach. There is another thing, that you can choose any of the educator to be your personal coach, and that educator is liable to help you throughout the preparation of GATE and ESE. And that educator will also track your study, help you to analyze those things. Suppose you are giving the mock test or practice tests, so proper analysis of that test would be done by the educator, and definitely that would be given to you, so that you may not commit the same kind of mistakes whatever you are doing it, and definitely your performance get boosted enough. Question and answer practices would be there, like you will be given the mock test, practice test, uh, question and answer practices, so that lots and lots of type of stock of the questions would be given to you, so that you may not have a need or urge to refer any or any other sources. So these are the top educators of the Unacademy, and definitely they are teaching in a very great way. And for GATE and ESE, Unacademy has lots and lots of batches for like year longs, for like different branches, for mechanical, civil, electrical, production, industrial. So you can always go and check out if you need. And these are the current changed plan of the plus subscription. So you can go for the, you can see the plus subscription is 5,500 for a 1 month. For a 3 month it is 13,750. For a 6 month it is 24,750. And there is a new plan that has been added, that is 18 months plan. So definitely you can go for it, like if you are in second or a third year. So definitely you can choose any of the plans, like 12 months, 18 months and 24 months. Definitely that would be going to be beneficial for you. But in any of the plans, if you are choosing it, use my code SIRVK, and whenever you will be using my code, you will be getting a 10% off, and the prices would be decreased. Suppose for if you are going for a 12 months plan, the prices you have to pay, that is only 27,225. So definitely you will be getting a 10% off, as well as I will provide a personal mentorship to you also. So always remember this SIRVK whenever you are going for the subscription. Definitely use my code SIRVK. So let's start our discussion. Good evening, Asis. Good evening. Okay, so let's start our discussion with the what we have started in yesterday's class. So we have started in the yesterday's class what we have started, and we have seen that there is a two kinds of loadings. That suppose that we are giving the bulk load. So if bulk load is there, that is huge amount, then that is categorized as, that is categorized by the four processes, that is forging, rolling, extrusion and drawing. Fine. So these are the four processes that we have seen. Now if, what if I'm giving a very light loads, suppose that if a thickness of the sheet is very less, we know that sheet is very less, of having a very less thickness. So if we are applying a very humongous amount of load, that sheet will break, that sheet will be nothing, no use. So we cannot use anything of that sheet, and definitely that sheet will rupture, and hence there is a need to apply a lighter amount of load. So whatever the sheet metal operations are there, we use the light loads. Fine. And we use the bulk load for these things. What are these things? Understand. So this is, first is A, let me write it, it is a forging operation. So what is the forging? I have explained you. So suppose this is the metal, understand, suppose this is the metal part, and this metal part is inside a die, right, is inside a die. So this is the die. Now on this die you are giving some kind of forces. Sorry. Now on this die, what you are doing it, you are giving some kind of forces. So compressive forces is there, right? Now see, when you are giving a compressive forces, either you can give the compressive forces from the external source, like by hammering, or by giving any like hydraulic machining, whatever you can give by use of hydraulic thing, you can give also the pressures. So whatever the by means can be different, but you are giving the some kind of compressive forces, right? Compressive forces. So when you will be giving the compressive forces, this metal part will take the shape of the die, right? So you can see here that this metal part has taken the shape of the die, and this entire process is known as forging operation. Okay, so this is all about the forging operation. Now what is this operation? What is this operation known as? See, this operation is known as, this operation is known as rolling operation. Okay, see what is in this rolling operations. So this is a roller, so these two are rollers that is actually rolling, and from here you will be given the metal parts, metallic part is fed from this end, and from this end roller is moving like this, roller is moving, this roller is also moving, and see, its size is getting reduced, fine. And what we can understand from here, that this metal part, whenever it is feed, so we know that rolling is what? Rolling is generally, rolling processes is hot rolling. We have discussed about hot working process and the cold working process in the yesterday's class. So generally the rolling is hot working process, so definitely the hot working process would be there. So we need some water cooling arrangement, so that whatever the hotness would be there, so temperature can be reduced, so that we can deform it in our required shape. So this is all about the rolling operation. Next operation is what? Next operation is, so see, this is the let me write it. So see what we are doing it. So this is the metallic part, this is the metallic part, and we are pulling this, from the outer part, and there is a small opening. So this is a small opening, and from this opening we are pulling it. So this process is known as drawing. So what is basically we can see in this drawing, see here, this was a diameter d, and this was also having this diameter d. So basically we are doing this diameter drawing to reduce the diameter of the metallic part. Next thing what is there? Next thing what we can see here, suppose what you are doing it, suppose you take a piston. Okay, suppose this is your piston, and with this piston arrangement you are giving some kind of force, so when you are giving some kind of force to this metallic part, this is moving out from this small opening. So again, this is a small opening, and hence what we can understand here, is, so that metallic part is getting extruded out. So it is extruded out, and this process is known as extrusion. Okay, so we have discussed these things, and these all comes under the bulk load. So whenever you are giving the bulk load, that is given, then this is forging, drawing, rolling, and the extrusion. Fine. So basically in this session what we are going to do, about the rolling operation. We are going to focus about the rolling operation. Okay, I will be teaching the new topic. Definitely, but that new topic, see, some of the new topics are in, if you could understand, the new topics are in metrology part, and definitely when I would be teaching you the metrology, I would be definitely incorporating those things. Next is the abrasive jet machining that has been added in this your syllabus of GATE 2021. So that also I will be teaching you when I will be teaching you the non-conventional machining processes. Fine. So I hope you understood your doubts. Definitely I would be solving the problems, but basically in this session we are going to cover all the concepts regarding this rolling processes, and from tomorrow onwards we are going to focus on the numerical questions. So we are like 2 sessions I have dedicatedly given for the rolling operations only, to solve the rolling questions. So this is the first session that was going to be. There is 2 more sessions that will, in that more 2 sessions I will be solving the problems, because questions from rolling is often asked, and these are very much important. Okay, so what is this rolling operation? So see here, you have just seen this rolling operation. So what is this? So there is a two rolls. So these are the two rolls. Fine. So these are the two rolls. So a process of plastically deforming metal by passing it between the rolls. Fine. So this is the process of plastically deforming metal by passing it between the rolls. So we have seen that we are passing this metal and it is plastically getting deformed. I have told you in yesterday's class what is the meaning of plastic deformation and elastic deformation. So I hope you understand this meaning. You understand the meaning of plastically deforming. right? So there is a plastic deformation. That means what? After the yield reaching the more than yield point, it's getting deformed, and whenever you are just removing the force, it is not going to get into your original configuration, and that is what is the meaning of the plastic deformation. Fine. So it is mostly used for high production and close tolerance. Friction between the rolls and the metal surface produces high compressive stress. Now there is a need to understand this process. There is a need to understand this process. Understand. So there is a roll. There is a roll. So this is the two rolls. Fine. So let us assume this is a center of the rolls. This is center of the rolls, and on this roll you are giving some kind of, okay, so this is your workpiece, you are feeding it. Now understand what is happening. This roll is moving in this direction. Fine. This roll is moving in this direction. This roll is also moving in this direction. So these are rotating. So these two rolls are rotating. Now understand, when these two rolls are rotating, so my workpiece will be in contact up to this point, and after that they will be like this. Fine. So my workpiece will be in contact again up to this point, and after that it will be reduced. So what you can understand here, that its size is reduced. Its size is reduced. And see here, since this roll is rolling, that is, it is rotating. So can you say that here the compressive force is acting? See here. So here the compressive force would be acting, right or wrong? So here the compressive force would be acting. So I can write here that compressive force is acting. Next, what? Understand. See, the rolling is this roll is moving in this direction. So what is happening when the roll is moving in this direction? So definitely what is happening here? So see here, when the roll is moving in this direction, so see, it is giving a force in this direction, and this roll is moving in opposite direction, so rotating in opposite direction, so it will give a force in this direction, right or wrong? So what is this? What is this? Can anybody tell me? We have got this kind of forces, that is, two forces are equal and opposite in nature. So what is this force? Can you anybody tell me what we say these kind of forces? Can anybody tell me? Can anybody tell me that what is the name of these kind of forces when we get equal and opposite kind of forces? What is the name? So see here, please give me the reply if you know. Yes, definitely, that would be free. I am teaching the manufacturing full course in YouTube. You can check about it, and that is totally free. Okay. Okay, so no problem. I think you do not know. See here, this is known as shear. Okay, this is known as shear. This is shear. Fine. So this is what we can understand here, that it is a shear force. So you have not given any answer. Okay, very good. So I got an answer from this kindly impact, and definitely that is a shear force. Very good, Asis, very good. So very good to everyone. So definitely that is a shear force. So always and always remember that metal will undergo into biaxial compression. And what is the exactly meaning of this biaxial compression? So in this metal, in this part, compressive force would be acting and shear force would be acting. Compressive force would be acting and shear force would be acting. Okay. Now see here. So this is what is the most important thing, that is, we have understood. Now see here, if a elemental part, suppose if I would take a very small elemental part like this. Suppose this is a very small elemental part I took here. So this is a small elemental part we have taken. Now if we want to check the state of stress. So if in examinations or if in an interview these questions are asked, tell me the state of a stress of a rolling operation. Tell me the state of a stress of a rolling operation. So what would be there? So you can see here the compressive force is acting. The compressive force is acting, yes or no? So can I say that compressive force would be acting like this, right or wrong? And there is no kind of no normal stress is acting in this direction. So in this direction no axis there, no stresses would be there. Now you, if you see here very clearly, there is a shear force that is acting in this direction. So can I write like that? Can I draw like that? The shear force would be acting like this. Fine. Now the shear direction is also, so this is also the shear force. So this is the shear force which is acting in this body. Now to compensate this, now if you will see it very closely, if you will see it very closely, see, it is rotating in which sense? It is rotating in which sense? It is giving a rotation, it is giving a rotation in a clockwise sense. So my body is rotating in a clockwise sense. To compensate this clockwise sense, what forces would be acting? So there would be a complementary shear stress that would be generating. I hope those who have done my strength of material classes, so they are relating with these concepts. So definitely the complementary shear stress will be produced, and this complementary shear stress will be in this direction. And this is the state of a stress. This is the state of a stress in a rolling operation. So any doubt in these kind of things? So hot working, unless not mentioned, assume that hot working is there. So assume that, I am again telling you, assume that rolling operation is always hot working process. Hot working process. If in question it will be saying that it is a cold working process, then only assume that it is a cold working process. So generally we have seen that there are two working processes, that is a recrystallization temperature is there. So if we are working beyond the recrystallization temperature, then definitely that process is known as hot working process, and when we are working below the recrystallization temperature, that is known as cold working process. So see, basically in rolling operation what is there? So we want to roll it, we want to roll this kind of metals. So if we want to roll it, so definitely we require some kind of ductility. And when we will be getting ductility? If we are raising the temperature more, so when we are raising the temperature very much, then we are going into the hot working processes. So generally it is hot working process. It is not like a thumb rule that rolling would be definitely a hot working process. No, it is not like that. In general cases it is, a hot working process. So I hope these things are very much clear to you. Good evening, Syam Babu. Good evening. Yes, I have explained you these things, compressive force and shear force, how these things are acting in these rolling operations. Fine. Okay. Okay. Now see here. What is a hot rolling operations? So just now I have told you what is a hot rolling operations. So see here, a rolling process in which a heated workpiece is pressed between the rotating roller to reduce its thickness. So we have seen here that thickness is always reduced. Thickness is always reduced. See this sheets would be like this, right? Sheets would be like this. Okay, so sheets would be like this. So basically the sheets is like this. So it has dimension in this part also. Okay, so we are seeing from the side view. Okay, so these are there. So what we can understand here, that thickness is reduced. And whatever the working we are doing it beyond the recrystallization temperature. So there is a recrystallization temperature, and when we are doing it above the recrystallization temperature, that is known as hot working process, and when we are doing it below the recrystallization temperature, that is known as cold working process. Fine. So the heat causes recrystallization of the grains. I have explained it in the yesterday's class very in a very great details how the recrystallization is going on, what is the change in the grain structure, what is a fine grain structure means, what is a coarser grain structure means. So these things I have explained it, so I hope you are relating those things with the today's class. Fine. So this is all about the hot rolling conditions. Now what is a cold rolling? What is a cold rolling? So in this cold rolling, what is happening? Rolling process in which a workpiece is pressed between the rotating rollers. So there is a rotating rollers we have seen to reduce its thickness. So see here, difference is in the recrystallization is there, in this here recrystallization is there, and here recrystallization is not there. So we know these things, right? So there is no change in the grain structure, there is no change in the grain structure. So basically one more thing that I want to ask from you, see, in the cold working process, I have told you about the concept of strain hardening. It is also known as work hardening. Now see, we have seen that what is a strain hardening, and see, when I would be increasing the temperature, when I would be increasing a temperature of a strain hardened material, then that internal resistive force that is actually acting in that body, that will be relieved. So what we say that when we are increasing the temperature, internal residual forces, internal residual stresses is going to release. So if I would be asking with you what is the strength, so let me write it here. So there is a cold rolling process and there is a hot rolling process. So if I would be asking you here the residual stress is absent, and here residual stress is present, Now understand, since residual stress is present in the cold rolling process, residual stress is getting relieved at the hot rolling process. So what we can understand from here, अभी मुझे आप लोग सभी बताएं कि सर आई वॉज हैविंग अ मटेरियल, इन दिस मटेरियल इंटरनल रेजिडुअल फोर्स इज कंटिन्यू, सो व्हाट वाज इट स्ट्रेंथ? इसका upper yield point, its upper yield point gets increased or not? So whenever the upper yield point of the material gets increased, so can I say that strength of the material gets increased? Yes or no? So we have talked about that whenever we are going for a strain hardening cases, so strength of material is going to be increased, and hardness is going to increase, now you can very much relate and tell me in which of the processes, that is either a hot rolling or a cold rolling, my strength would be more. So suppose there are lots and lots of the hot working processes, there are lots and lots of the cold working processes. So if in any time, in any question, it has been asked to you that tell me the strength, in which case strength will be more, in hot working process or in cold working process? Tell me, strength will be more in hot working process or cold working process? Tell me, what do you think? Yes, Yam Babu, tell me, what is your problem? I cannot understand you. Definitely Jagannath ji, I would try to bring the heat treatment processes also. See, I am going in a like a very chronological order, in a very structured manner, so that you may not face any problem. So after the forming, so like lots and lots of chapters are there, so I will definitely take this material science part also. Okay, so tell me, in which process, in which working processes my strength will be more? Okay, so very good. Cold working process, very good, so Ashish has told cold working process and Syam Babu has told, very good. So see here, if I would ask with you, here, forging is a hot working process or a cold working process? So definitely this is a hot working process. Rolling is also a hot working process. Generally. Drawing is also a hot working process. Extrusion is also a hot working process. So always keep in your mind, whenever you are seeing any kind of process, think about it. Is it a hot working process, or it is a cold working process? And if it is a cold working process, then only I can see here, then only I can say here, strength will be more. Why strength will be more? Because we get a strain hardened material there. Because when I will be increasing the temperature, my residual stress is zero, my residual stress is relieved here. Okay, so I am pretty much sure that you all have understood this concept very well. In the gate, this question is asked. Okay, so these kind of questions are asked, so definitely you have to clear your concepts. Now understand what is happening in a hot rolling process. So see here, my dear friend, at this point, before going into this roller, so this roller is rotating in this direction. Okay, so this roller is rotating in this direction. Now you can understand from this, so this is the microstructure. So grain structure is like this. So before entering into this roller, my microstructure is like this. So grain structure is like this. Now when this material has undergone into what? This material has undergone into compression. Fine. And there is a shear also. So compression and shear. So compression and shear is there. So definitely the complementary shear is also acting like this. So when this body is subjected to these kind of things, these kind of state of stress, so what is happening? See the change in the microstructure, change in grain structure. So you can see the changes. So what we can understand here, the crystal structure changed. And it has taken a new form, and definitely that is known as recrystallization. मतलब क्या? What is the meaning of re? फिर से, again. Crystallization means what? Changing the crystal structure. So when you are again and again changing the crystal structure, that is known as recrystallization. Fine. Why? see if you could see here what I have explained here. See, this roller is see here, this roller is rotating in this direction. Okay, so it is rotating in anti-clockwise. Suppose this is rotating in anti-clockwise. So if it is rotating in anti-clockwise, so see here, this much part of the metal is what? It is in contact. So this much part of the metal part will be pushed in which direction? It will be pushed in this direction. Fine, it will be pushed in this direction. Now see, it is rotating in. Okay, so see here, it is also rotating in this direction. So it is also rotating in this direction. So when it will be rotating in this direction, okay, just a minute. So see here, when it is rotating in this direction, so what is happening? Since this part of the metal is pushed up in this direction, so this part of the metal is pushed in this direction. Okay, so there is a like complementary thing which is forming here. Okay, so I hope you understood now. Okay, now try to focus here. So basically what is here, in hot rolling process, the workpiece, usually a sheet blank, is preheated to its recrystallization temperature and fed between the two rotating rollers. So basically see, this is a red hot, so its temperature is what? So this is a red hot. So see, basically what we can say here, we cannot feed anything in this roller. So before going into the feeding into this roller, we are preheating this slab. Fine. So when we are preheating this slab, what is happening? The recrystallization temperature is achieved. So it is fed into these two rollers. Fine. So these are the rolls. These are the rolls. Fine. Now the rollers compress the plate. The rollers compress, see there, the rollers compress the plates, so that is its thickness decreases. We have seen, see, this is the thickness. This is the thickness. So earlier this was the thickness. So let me write it like H1. So suppose this is the H1 and this is the H2. This is the H2. So what we can understand here, that earlier there was a thickness, that is H1, and this is now H2. So thickness is reduced. Fine. Thickness is reduced. So roller compresses the plate, so its thickness is decreases. Fine. Now understand, as the material undergoing this process, recrystallized new grains are created after rolling. We have seen, this is the new recrystallized grains we have seen, and which provides more isotropic properties than the cold rolling. What is the meaning of isotropic properties? If you have done my classes, so you are knowing that what is the meaning of isotropic, homogeneous, orthotropic. What is the meaning of this? See here, if we are seeing any kind of property from any directions, so from any direction, from any way, if we are seeing those properties from that directions, the property is going to remains same. So we are getting a uniform property throughout the cross section, and that is known as isotropic in nature. So basically in hot rolling, the main advantage is that we are getting the isotropic properties. Fine. And what are the things that we have seen in the yesterday's class? In yesterday's class we have seen that in a hot rolling, or in a hot working process, my mechanical strengths or my mechanical properties get enhanced. Okay, so whatever the mechanical properties I will be getting, that would be isotropic in nature. Now understand this. So understand this. What is the benefit? So what is the benefit of this hot rolling process? So benefit is that it results in fine grain structure. So see here, fine grain structure is there. Surface quality and final dimensions are less accurate. I have explained you why the surface quality and the final dimensions would be less accurate. Why? See here, because the temperature is more. See, in this case, understand, temperature will be more, that is a very high temperature would be there. So whenever the high temperature would be there, so at the high temperature its ductility will be more, so metal will flow. So ductility will be more, so when ductility will be more, metal will flow. So to give a proper direction, or to make any close tolerance objects, it is difficult to handle those flowability. So hence ductility will be more, so we cannot control its accuracy. We do not have the control over its accuracy. This is the first thing. Next thing is what? See, more temperature is there, so it may be subjected to the oxide, that is the atmospheric gases that would be present in the environment. So whenever they are subjected to the atmospheric gases, so definitely there is a chances of oxide layer that is going to form. Now when the oxide layer will be forming here, स्केलिंग वुड बी देयर, स्केलिंग ऑफ द सर्फेसेस, है ना. आप कभी भी किसी मेटल्स को देखें, सपोज करें उसको गर्म कर देते हैं, बाहर का कैसे जो कवर होता है ना, बाहर का जो फाइबर होता है, एक्सट्रीम फाइबर, वो कैसा खुरदुरा हो जाता है ना. सो देयर इज स्केलिंग, दैट इज नोन एज स्केलिंग. सो स्केलिंग occurs, and hence when the scaling would be occurring, surface quality would be very much poor. Fine. So I hope you understood these 2 points. Now understand this. What is happening in the cold rolling process? Fine. So this is again the rolls. And see, in the cold rolling process, there is no not that much amount of grain structure is changing. So no, here the grain structure is changing in a drastic amount, but in this case the grain structure is like near about it is not changing. Fine. It is not changing. So see, understand what is a cold rolling process. So I have told you earlier that in the 50%, so whenever you are getting the reduction of the 50%, So understand. The workpiece, typically a sheet metal blank, is fed between rotating rollers without preheating. So see here, in this earlier case, we were preheating this thing, and we, after preheating, we are feeding in these rolls. Now in this case, we are not preheating this, feeding it. The rolls compress the plate so that its thickness is reduced up by 50%. So see here, the thickness is reduced by the 50%. So see, this was the thickness earlier, this was the thickness. Let us assume this to be h1, this to be h2. Similar in this case, what we have assumed, this is h1 and this is the h2. Fine. So there is a reduction in the thickness. So see here, so definitely there is a reduction in the thickness. Shape changes is without recrystallization. So we have seen that there is a reduction in the shape. So thickness changes, shape changes, and there is no change in the crystal structure. Why there is no change in the crystal structure? Because it is a cold rolling process, and the speciality of the cold rolling process is that we are working below the recrystallization temperature. Fine. Now see, we are working in the below the recrystallization temperature, hence we are getting the surface smoother. I have explained you why we will be getting the surface smooth. That is the good quality of surface finish. Can anybody tell me why we are getting the surface finish? Very good. Can anybody tell me why we are getting the surface finish? Very good. Okay, try to understand here. So what is the problem here? In this problem, the problem is there. See, understand here. Understand the problem. If you can identify the problems, you definitely can understand the things. What is the problem? So here the problem is oxide layer forms. And oxide layer is forming, and hence scaling is there. Scaling is there. Scaling is there. Now understand, when the oxide layer is forming, why oxide layer is forming? Why oxide layer is forming? Earlier, this metal is subjected to elevated temperature. Now the elevated temperature, now at the elevated temperature, material has a tendency to form the oxide layer. Now when the oxide layer will be formed, the scaling would be there. Like suppose this is the metal, so on the metal part, my scaling would be like this. ऊपर का जो होता है ना part, वो कुछ scale formation करता है, and that is the scaling, and hence we are not getting the good surface finish. Understand, one more point is there in this. This is the roll, and this is very hot. You can say that this is hot. Now when the material will be hot, can I say that roll marks है ना? सपोज करें कि कोई भी चीज अगर गर्म हो, और क्या है, गर्म चीज के ऊपर आपने अगर कोई हथौड़ा मार दिया या कुछ भी कर दिया, तो क्या हथौड़ा का मार्क उस गर्म चीज के ऊपर रह जाएगा? यस और नो? टेल मी. सपोज दैट इफ यू हैव अ वेरी hot material, and in that hot material you are hammering it, you are doing some kind of, giving some kind of forces with the rolls. So will the roll marks or the any kind of marks would be subjected on this material or not? Yes or no? Yes. So definitely the cut marks or that marks of that roll would be on the material, and definitely for these kind of reasons I'm not getting a very good quality of surface finish. We are not getting the good quality of surface finish. Understand or not? Now see, whereas in this condition, see the rolls in these conditions, what is happening? This is cold working process, so no chances of mark. Any kind of mark will not be there, and definitely when any kind of mark will not be there, definitely my surface quality will what? Will enhance. Yes or no? And see, there is no problem of oxide layer also. Why? Because temperature is very less. Do you know, I have told you the recrystallization temperature would be 0.3 to 0.5 of the melting point of the temperature, melting point of the material. Right or wrong? So see, suppose what I can say here, that if the melting point of a material is 1000 Kelvin, if the material melting point of the material is 1000 Kelvin, so that recrystallization temperature will be what? Suppose it is that is the alloy. So for alloy, recrystallization temperature would be 500 Kelvin. Now at this is a very less, this is very less amount of temperature, and at this temperature there would be no marks, there would be no marks, and at this temperature definitely no formation of oxides, no oxide formation would be there. And definitely for these kind of reasons we are getting a very good surface quality, so surface becomes smoother. Understand or not? Understand or not? Now one more point is there. See here, see here, suppose the material is like this. Suppose, see here, earlier the grain structure is like this, yes or no? So grain structure is this, grain structure is this. Here what is happening, here what is happening, when they are when they are in compression, what is happening, the grain structure is like, looks like this. Okay, so they are like compressed, they are compressed like this, they are compressed like this, fine. So what is happening here, what is happening here, grains do not recrystallize and materials show anisotropic properties, because see the grain structure is very much different in this case also. After this it is squeezed. So basically what you can say here, the grain structure is squeezed, it is squeezed. So after squeezing, at some point more squeezing would be there, at some points less squeezing would be there. So for these kind of conditions you are getting the anisotropic properties, anisotropic properties. So I hope you understood these things. Now one more thing that we always have to understand, this is what products are: sheet, strip, foil. So you are making basically the sheets, strip and the foil with these kind of rolling operations with good surface finish, good surface finish. So always keep in mind cold working process. So even if, so whenever in the examination when you read a term, what is that term? Cold rolling process, or better to say cold working process. So after seeing that cold rolling process, you should always have this much clarity. What is the clarity? Sir, cold working process, cold working process means the strength is going to increase, fine. Ductility, sir, strength agar zyada hoga, if strength is more, whether that material will have ductility more or less, no, if that strength would be more. See here, if this is my material and its strength is more, so if its strength is more, so it is rigid, it is not ductile. So what we can say here, if strength would be more, ductility will be less. Now if in it we are using a cold working process, so surface finish would be increased. Clear? So these things that should always and always be in your mind. What is the meaning of cold rolling process? See, you can study anything, you can study books, you can study NPTEL lecture, you can study anything, but most important point is the gist. And this is what is the most important thing, that see here, by seeing the cold working thing only, you should always keep in mind that strength should increase, ductility should decrease, surface finish should increase. Any doubt? Any doubt throughout these things? Any doubt throughout these things? If you do not have any doubt, then I will be starting a new topic. Please explain once more. Not understood, sir, but okay. What part you didn't understood? Battlewing and Ashes. Okay, no problem. So if I would recommend you to watch it again if you have any kind of problem. Okay, if you have any kind of problem, so definitely you rewatch the videos. Okay, okay. So now let's see some new thing, that is rolled ring. What is the meaning of rolled ring? What is the meaning of rolled ring? See here, we are producing these kind of rings. This is a ring, this is a ring. So we are producing the ring, from these kind of workpiece. So what is this workpiece? So there is a workpiece like this, which is cylindrical in nature, and there is a hole, right? So there is a hole here, so it is a pierced workpiece. So what exactly we are doing it? So in this pierced workpiece is fed in this. So this is known as idler roll. So this is known as idler roll. So first of all, understand understand this process. Okay, let me give you the example. See, this is the example of real what is happening in the industries. Okay, so this is what is happening in the industries, and try to understand by these figures what is exactly happening in the industry. So see, this is the what, this is the idler role, this is the idler role. Just let me take it. This is what, this is idler role. See here, this is the idler role, understand or not? So this is the workpiece, this is the idler role, and see, this is the idler role. So what is this? Is it workpiece? So this workpiece is pierced, see here, it is pierced, and this pierced workpiece is fed in the idler role. And what is this? You can see here, this is another role. See here, this is a role, this is a role, you can see here, and this roll is rotating in this direction. Fine, this roll is rotating in this direction, in this direction, in this direction. So what is this roll? This is a driving roll. See, what is the driving roll? So this is the drive roll, this is the drive roll. Fine, so let me write it here. This is what, this is the drive roll. So I hope you can visualize these things. So there is a workpiece, that workpiece is pierced in nature, and that workpiece is fed inside the idler roll, that is the roll, and this is the drive roll. What is being then? Now see, this arrangement is moved towards the drive roll. See here, see here. So this arrangement is moved towards the drive roll. So it is moved towards the drive roll like this. Now see, it is in the contact. Now it is in the contact, and this drive roll is rotating in this direction. Fine, this drive roll is rotating in this direction. This is the idler roll, this is the idler roll, this is the workpiece, and this is the drive roll. Fine, this is the drive roll. Now what is happening? Now what is happening from this side, from this side, from this side? See here, two axial rolls will be coming. So what is this two axial rolls? Try to visualize it, try to visualize it here. See here, what is there? These two are the axial rolls. Okay, these two are the axial rolls. This is what, this is your workpiece, this is what, this is your idler roll, and this is what, this is rotating in this direction, and these are rotating in this direction like this. Fine, so these are rotating in these directions. Now see, this is rotating in this direction. What is this? This is a drive roll, this is a drive roll. So they are moving in this direction, they are moving in this direction. So this is upper part, so upper part will be on this upper part of the workpiece, and this lower part of this lower axial roll will be in the lower part of the workpiece. Fine, so understand here, understand here. So they have reached here, they have reached here. So when they have reached here, when they have reached here, what is they going to do? So this will be on this upper part of the workpiece, and this will be on the lower part of the workpiece. Now what will be happening? So this is rotating, this is rotating, this is rotating. Now see, you can see here, due to these kind of rotations, due to these kind of things, what is happening here? What is happening here? Understand what is happening here, understand. This is, I have told you what, this is the rotating. So this is the axial roll, this is the axial roll. So this axial roll is fed on the upper part of the workpiece, this axial roll is put in the lower part of the workpiece. So what is happening? This lower part we cannot visualize. This is the axial roll which is on the upper part of the workpiece. This is what, this is the idler, this is the idler, and this is what, this is the drive roll, this is the drive roll. And from these things what we can see here, it is rotating. So it will rotate like this, it will rotate like this, and when it will be rotating in a very high speed, it will be forming the ring. Yes or no? So I hope you visualize these things, how in the industries, in the manufacturing unit, the rings are produced with help of the rollers, and that's what is being shown in this figure. There is a workpiece, There is a drive roll, idler roll, axial rolls are there. This is rotating, so this is also rotating, this is also rotating. Each and every fixtures is rotating, and when it is rotating, so ring is produced, so this is the finished product. So this is the finished product. So this was the workpiece. From workpiece to finished product, we have got the ring, and this is all about the rolled ring. This is all about the rolled ring. So this is called as ring rolling operations. This is known as ring rolling operations. So what is the meaning? So just now what we can conclude from these ring rolling operations, that ring rolls are used for tube rolling or ring rolling, right? So either we want to make a tube or we want to make a ring. Next thing is what? As the roll squeezes and rotate, wall thickness is reduced and the diameter of the ring increases. Definitely. See, understand the logic. Volume remains constant. Suppose what this is, suppose this is pi by 4 d square h is there. Suppose this is a cylindrical thing. Now what you can understand, basic is there. Since volume is going to be constant, so if diameter is increasing, the height should decrease. So what we can say here, the height should decrease. So if diameter is increasing, height should be decreasing. So this is the basic thing, because volume is remains constant, and that's what is written here. As the roll squeezes and rotate, wall thickness is reduced and the diameter of ring increases. Fine. Next thing is what? Shaped rolls can use to produce a wide variety of cross sections profile. ठीक है, बहुत तरीके का क्रॉस सेक्शंस प्रोफाइल बना सकते हैं. कैसे? अगर मैं शेप्ड रोल को दे दूं, व्हाट इज द मीनिंग ऑफ शेप्ड रोल? सी हियर, we have these kind of rolls, that is the axial roll, which is conical in nature. If I would be making these kind of rolls, suppose these kind of roll is there. Just a minute. Suppose if I have made these kind of roll, this is the axial roll. Now whatever the impressions in this roll would be there, that impression would be subjected to the workpiece, and hence we will be getting a different types of cross section, different types of cross sections and the profiles if I will be making any shaped rolls. Fine. Ring rolls are made of spheroidized graphite, benite and pearlitic matrix or alloy cast steel base. Now you may not understand these things. Basically in the material science, this is ferrite are there, ferrite is there, perlite is there, martensitic is there, benite is there. So these things are the grain structure. So don't get focused here. Don't worry if you cannot understand here. Just remember this point. When I will be explaining the material science, definitely you would be understanding these things, because see, this is like little bit, if I would be explaining these metrics, then definitely that is going to be the out of context. Okay, so these are the points of ring rolling. Let us move. So if anyone has any kind of doubts throughout it, you can always ask with me. Thank you so much, Bijap. I always try my level best to give the good content, because definitely it's like it is very much क्या होता है ना, नाइंसाफी हो जाती है. मैन्युफैक्चरिंग तो पूरी की पूरी आपको मैन्युफैक्चरिंग जो है या तो वर्कशॉप में दिखेगी या तो किसी इंडस्ट्री में दिखेगी. अगर मैं उस मैन्युफैक्चरिंग को आपको इस लेक्चर के टर्म्स में बताऊं, ये तो सरासर नाइंसाफी हुई ना. So definitely you will not be able to visualize those things, and I try my level best so that you can visualize what is happening in reality. Okay, so okay, no problem. So I hope you have understood these things. What is this sheet rolling? Another process is sheet rolling. So what is happening here? So this is the sheet and this is the roller. Okay, so this is the roller and this is again the roller. So between these two rollers, that is the roller 1 and the roller 2, this is the sheet which is actually rolling, So sheet rolling, we are only attempting to reduce the cross-section thickness of the material. So whatever the thickness is there, our intention is to reduce the thickness. nothing else, nothing else. So this is basic sheet rolling operations है ना. sheet को डाल दिए हैं, वो reduce हो रहा है. So I hope it is clear to you. Nothing so much new in this concept is there. Next is what? Next is roll bending. What is this roll bending? What is this roll bending? Understand. So understand what is happening. So this is what, this is your sheet, this is your sheet, or the metal is there. Now understand. So this is fade in this direction, it is fade in this direction. So my aim is to bend, my aim is to bend the sheets, my aim is to bend the sheets. So there is an adjustable roll here, and these are the two driving roll which is rotating in this direction, which is rotating in this direction. So what is there, what is they are doing? They are rotating in this direction, this is rotating in this direction. So what is happening? My sheet is bended, my sheet is bended, and after the bending, after the bending, I will be getting these kind of structure. These are my finished product. So let me write like that, these are my finished product. So this is A. So here operations is going on, so operations is going on, and this is the finished product that we are going to get. Now you can understand this by this figure also. See here. So what is this? What is this? See, I have told you there is an adjustable roll in this way, and these are the two driving roll. So see here, can I say this is workpiece? Okay. Now what I have told you, there is an adjustable roll that actually adjust the shapes and size. Suppose if we get like thickness is more like this, so suppose the thickness is more like this. See here, what is the thickness? Can we say this is the thickness? Fine. So see here, so what we can say here, this is the adjustable roll. So this is the adjustable roll. Just let me change the color. So this is the adjustable roll, adjustable roll. Fine. So why this, why, what is the use of this adjustable roll? So based upon the thickness, this roll will adjust that. You can lose it, and you can adjust your workpiece based upon the thickness of the workpiece. These two are the driving rolls, these two are the driving rolls, and these are rotating, and hence you are getting the your workpiece to be bended, and hence bending is done, and hence bending is done. Fine. So what you can understand from here, it is a continuous form of 3-point bending. So 3-point bending is there, first point, second point, third point. So 3 point of bending is there, is roll bending. It is known as roll bending, where what, where plates, sheets and rolled shapes can be bent into a desired curvature on forming rolls. So what we are doing it, we are giving the curvature. So curvature are imparted. What is this? Upper roll being adjustable to control the degree of curvature. Very good. So that is we know that. So based upon this adjustable roll, my curvature is going to increase. See here. Can I say that? Can I say that I have this kind of curvature? Okay, so this is what is my curvature. This is what is my curvature. This is what is my curvature of this sheet, of this metal. Fine. So if I would be changing the places of this adjustable roll, so based upon that, my curvature size would differ. Fine. So I hope you understood the meanings of each and every points, and you don't have any kind of doubts. Okay. Okay, so let's move about the thread rolling operations. What is the thread rolling operations? What is the thread rolling operation? So see here, what is happening in this thread rolling operations. So these are the two dies. So these are the two dies, and basically these dies are roller. Okay, so these are the two rollers die. Fine. So these are rotating, so these are the rollers. See here, I have drawn the side view is also there. So what you can do here, so this is at the cross section, what you can understand. So this is the it is rotating in this direction, it is rotating in this direction, again this is rotating in this direction, and whatever the workpiece that you are feeding here, so this is the workpiece. So on this workpiece, my thread will be formed, my thread will be formed. So with help of the rollers, you are actually making the thread, and that is known as thread rolling operation. Fine. So what is this? You can visualize from this also. What is this? You can visualize from this also. Okay, so these are the roles. So these are the rollers, and this is the workpiece. What is cross section, sir? What is cross section means what? In which case you are talking about? Please be specific, Rakib, because I don't know what you are asking. Please reframe your question once again. What is cross section? Oh, okay, okay. What is cross section? See, see what is cross section. Okay, that is very easy. Suppose, suppose, suppose. See, okay, just a minute. Before that, see if this is, suppose if this is a rod, fine. If this is a rod, so if you would make this rod, if you would make this rod from this part, so you make like this, right? This is the rod. Suppose this is the isometric view. Suppose this is the isometric view. So in this isometric view, this is the rod. So in this rod, what is the cross section? This is the cross section. So if I will be drawing a cross section of this rod, that would be side view. So we can see like this. So this is the cross section. This is the cross section. This is known as the cross section. That is diameter. That is diameter. Fine. So this is the cross section. These are basic things. Okay. So I hope you understood now. I hope you understood now. No problem. You can ask anything. So basically, what is a thread rolling operations? So basically, what is a thread rolling operations? It is used to produce threads in substantial quantities. So in a huge quantity, if you want to make up threads, definitely you can use this thread rolling operations. So basically it is a cold forming process in which threads are formed by rolling a thread blank between a hardened dies that cause the metal to flow radially into the desired shape. Just a process that has been written in here, है ना? कैसे होता है? मैंने आपको बताया कि रोलर्स होता है, ये रोलर्स मूव करते हैं इस डायरेक्शंस में, एंड देयर इज अ वर्क पीस, एंड दिस वर्क पीस, ऑन दिस वर्क पीस द थ्रेड इज बीइंग इम्पार्टेड, द थ्रेड इज बीइंग इम्पार्टेड. मोस्ट इंपॉर्टेंटली इट इज अ कोल्ड वर्किंग process. Fine. So cold forming process is there. No metal is removed. Greater strength. Why greater strength? Why smoother? Why harder? Always remember. Always remember. I have told you. I have told you. Where I have told you. Where I have told you. I have told you one thing. Always and always keep in mind, whenever there is a cold working process, strength would be greater, ductility would be less, surface finish would be more, and hardness is always less. Because see, आपको याद रखना है कि स्ट्रेंथ को और हार्डनेस को हम हमेशा एक ही तराजू में तोलते हैं. मतलब व्हाट? मतलब ये होता है कि if strength would be more, hardness will be more. Strength would be less, hardness would be less. So from these conditions, what you can say here, you can very easily say what I have written here. Now you can satisfy, now you can understand that no metal is removed, greater strength. Why greater strength? Because it is a cold forming process. Smoother, so surface finish is more. Why surface finish is more? Because it is a cold forming process. Next one, it is harder, so hardness is more. So when hardness will be more, so if we say that any metal has a very much hardness, that we say the diamond is very harder. What is the meaning of the harder? It means that if it is subjected to any kind of indentation, it can resist that kind of indentation, right? So wear and tear would be less. So definitely for wear resistance would be more. वियर रेसिस्टेंस जितना ज्यादा होगा तभी तो वियर एंड टियर लेस होगा, है ना? वियर रेसिस्टेंस मतलब वियर को सहने की क्षमता जितनी ज्यादा होगी तभी तो वो कह सकते हैं कि वियर एंड टियर लेस होगा. फाइन. So these things are there in the thread rolling operations. Next is what? Major diameter is always greater than the diameter of the blank. Fine. So basically this is the diameter of the blank. Suppose this is the diameter of the blank. This is the diameter of the blank. So we are talking about this blank. So basically sometimes in the gate it has been asked that what you can tell about the major diameter and the diameter of the blank. Blank diameter is little larger, that is somewhat around than the pitch diameter of the thread, and is restricted to ductile material. Most important, throughout this I have written, this point is the most important point. It is restricted to the ductile material, that whatever the ductile material is there, you can do the thread rolling, you can do the thread rolling only in the ductile material, only in the ductile material. Why you can do the thread rolling in the ductile material? If you could visualize from your intuitions only, you can see here that, see, this is a roll, this is a roll, and this is the workpiece. So if this workpiece would have been like a brittle in nature, so what would be happening? If that is brittle in nature, so this workpiece will be broken down, it will subjected to the fracture, because due to this what is happening in the rolling operation? What you are doing it, you are giving the compression and the shear, compression and the shear. And let me tell you one thing, that when you are giving the compression, when you are giving the compression, the brittle material is failing, the brittle material fails at the compression forces only. Understand or not? compression देंगे ना तो brittle material हमारा fail कर जाएगा. Okay, so these things are there, compression and shears के कारण हमारा failure होता है, and that's why we are not using the brittle materials and we are using the ductile material. So I hope you understood these things. One more point is there. So any doubt till now? Any doubt till now? Just let me know. Do you have any kind of doubts? Sir, in ductile strength is less. Yes, yes. But see, material is ductile. Material is ductile. But process is what? Is this process cold working process? Material is ductile, definitely material is ductile, but is this process a cold working process? Right or wrong? So if it is a cold working process, see, if it is a cold working process, so whenever the process is cold working, I will be getting these kind of properties. Understood or not? Understood or not, Asis? Just let me know. हॉट वर्किंग प्रोसेस में होता क्या है, हॉट वर्किंग प्रोसेस में मटेरियल डक्टाइल हो जाता है. इसका मतलब ये थोड़े है कि अगर आप कोल्ड वर्किंग प्रोसेस डक्टाइल मटेरियल में करेंगे तो उसका प्रॉपर्टीज वैसा नहीं होगा, नहीं. इफ दैट इज योर कॉन्सेप्ट, रिमूव इट. दिस इज द बेसिक कॉन्सेप्ट. ओके, great, great. Now understand the barreling effect. What is this barreling effect? Now understand what is happening in this roller. See, do not favor ductile means what? See what is happening. Suppose if you have a ductile material, सपोज इफ यू हैव अ डक्टाइल मटेरियल, तो सी, अगर आप डक्टाइल मटेरियल को, सपोज आपके पास माइल्ड स्टील है, आप क्या माइल्ड स्टील को हैमरिंग करके आप डिफॉर्म नहीं कर सकते हैं क्या? कर सकते हैं ना. तो डेफिनेटली यू कैन डू इट. अगर आप माइल्ड स्टील को, दैट इज अ डक्टाइल मटेरियल, विद हेल्प ऑफ द कोल्ड वर्किंग प्रोसेसेस, इफ यू आर डिफॉर्मिंग इट, if you are changing its shape and size, so definitely you will be getting like a योर प्रोसेस विल बी देयर, है ना. आपको डेफिनेटली प्रोसेस प्रॉपर्टीज चेंजेस मिलेंगी. क्यों प्रॉपर्टीज चेंजेस मिलेंगी? क्योंकि कोल्ड वर्किंग प्रोसेस है. अगर आप माइल्ड स्टील को हॉट वर्किंग प्रोसेस में करते हैं तो आपका प्रॉपर्टीज डिफरेंट मिलेगा. इट्स जस्ट अबाउट द प्रॉपर्टीज, इट्स जस्ट अबाउट द प्रॉपर्टीज. फाइन, फाइन. ओके, अंडरस्टूड और नॉट? Understood or not? What is the difference between wear and tear? Okay, okay. See here, what is the difference between wear and tear? Rakib ji, if I would be asking with you, आप कभी बोलते हैं खाना पीना, खाना पीना खाना है मुझे, है ना, खाना पीना हो गया क्या? बोलते हैं ना खाना पीना, चलना वलना, देखना वेखना. दैट इज द सेम टाइप. वी से टूटना. फूटना, wear and tear, टूटना फूटना, wear and tear. Okay, understood or not? This is what is the meaning. Okay, now let us talk about the barreling effect. Let us talk about the barreling effect. Now see, suppose if you have a roll, so this is a roll, this is a roll, right? So this is a roll. Now suppose this is a roll and these rolls are in this condition before the rolling process. Okay, so this is the before the rolling process. Now suppose, let me write it here, this is the before rolling process. Rolls before the process. Now what is happening if you are, so these are the rolls. Okay, these are the rolls, and when these in this roll the workpiece would be there somewhat like that. What is happening in that condition? What is happening? You are getting these kind of configuration. Let me draw it and then I will explain it. Now understand this question. Now understand this point. So this is a roll in earlier case. Now the roll is like this. Now the roll is like this. Now what is happening when you have given the workpiece? So whenever the workpiece is there like this, suppose this is the workpiece. Suppose this is the workpiece. So what is happening in this case? What is happening in this case? So since this rolling operation is continuously carried out, so due to this continuously carrying out the rolling operation, so what we can see here at this point, greater forces is there. So forces are acting. So forces are acting. Due to this forces, what is happening? This like roll, this roll is deflected towards the middle. So it is deflected, in this direction. Fine, it is deflected in this direction, and you will, your earlier roller was like this, now roller is like this, now roller is like this. So there is a difference in the cross sections and the area. So what we can understand here, that if I will be using any workpiece during this rolling operation, so what is happening? Deflection causes the workpiece to be formed with the barrel shape. What is the meaning of barrel shape? See, the product will be manufactured like this. That the product will be manufactured like this. This is the barrel shape. This is known as barrel shape. This is known as barrel shape. Fine. This is known as barrel shape, right? So what is happening here? What we can understand here? Let me take it like that. So here, what is there? Greater forces towards center, and hence deflects the roll more in middle. And see, what we can understand from this, this is that deflection deflection causes workpiece to be formed with a barrel shape. With a barrel shape. Okay, नाउ देर इज अ प्रॉब्लम. सो दिस इज द प्रॉब्लम कि पहले रोल्स हमारा इस तरह का था, अभी रोल कुछ इस तरह का हो गया. तो अभी तो मेरा बैरल शेप हो रहा है, मुझे चाहिए इस तरह का वर्क पीस, बट मुझे मिल रहा है इस तरह का वर्क पीस, right? And I don't require this. So what should I do? What should I do? So in the casting, when I was teaching you the casting, I have told you that we give a allowance that is known as camber allowance. How many of you can remember the camber allowance? I have told you in the casting what is the camber allowance. So in that camber allowance, what we are giving, that we are making these rolls in a very different shape. Let's see what is the camber allowance. How many of you can remember that camber alliance? So in that camber alliance, what we are doing it, we are making the rolls in a barrel shape like this. Fine. So this is the cross section. So this is the center line. So what we are doing it, we are making the rolls camber, we are giving it. So what we can say here, rolls with camber. So what we have done it, we have made a camber arrangement, and when I will be, when, so this is the condition where rolls before process. So this was the conditions, rolls during process, rolls during process. Now what is happening, rolls during process. So if I would be drawing a rolls during process, what is happening in this case? So in this case you will be getting the this kind of things. So now this is going to be flat again, this is going to be flat, this is going to be flat. Due to this camber, what is happening now, when you will put the workpiece, suppose this is the workpiece, like this, like this. So this is the workpiece, so this workpiece. So what is happening here, what is happening here, so what is happening here, so due to this camber effect, you have made the camber. So due to this camber effect, what is happening here, so camber offsets roll deflection, right? So earlier you were getting the roll deflection like this. So this was the roll deflection, right? See here, what is the meaning of roll deflection? See here, the roll is deflecting like this, right? So 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 see here, if you would visualize like this, so roll has deflected like this. Now this was the actual position. So can you say this is the deflection, this is the deflection, this is the deflection, right? So this is the deflection that you are getting. Now camber offsets the roll deflection, and 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 hence workpiece workpiece is rolled flat. So now what is happening, now you are getting a flat workpiece, right? So now you are getting a flat workpiece. Earlier you were getting a these kind of workpiece, barrel shaped workpiece. Fine. So this is what is the discussion of camber allowance. This is what is the discussion of the camber things. And so that's why 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 rolls with camber eliminates roll deflection. So these concepts are very much important. We are going to see these things, we are going to talk about the rollers throughout the discussion. So definitely before going into those discussions, these things are very much important, so that we can understand the physics behind these things, and definitely that would be enhance your knowledge. Now tell me the answer, tell me the answer of this question, tell me the answer of this question, that in a rolling process, state of stress, I have told you about the state of stress of the material undergoing deformation is. Can you tell me the answer? Can you tell me the answer? Please tell me the answer. Please tell me the answer. Very good, very good. Kindly impact, very good. So we have seen that the state of stress is this. Okay, there is a compression, there is a shear, and there is a complementary shear like this. Fine. So this is the state of stress. So I hope you are understanding the concepts whatever I have told you. Because see, my dear friend, do not understand in this a fashion. If you think like that you can score a very good marks in manufacturing without understanding the theory, no, 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 please don't do it. Please don't do it. If you are thinking like that, don't do it. Numericals, of course, numericals are very much important, but theories are also important. Theories are also important. I'm not telling that study everything. Don't, no, 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 no. अरे कितना पढ़ना है वो एकदम जरूरी होना चाहिए कि पढ़ना आपको बहुत कमी है, ज्यादा पढ़ के आप कुछ नहीं कर सकते, but definitely theories is very much important, and please focus in theories also. Okay, then only you can score a very good marks, about 18 to 20 marks, full marks in the manufacturing. Okay, good, good, good. So compression and shear is there. So very good, Ashish, Sohel, everybody, very good. Now tell me the answer. Consider the following characteristics of the rolling process. So it is showing, so these points are there, 1 2 3 are there. Which of these characteristics are associated with the hot rolling? Tell me the answer. Tell me the answer. Try to solve this question and tell me the answer. Okay, so Asis has given the answer 2 and 3. Very good. Option C. Very good, very good. Anybody else? See, whether you are committing the mistakes, that is not a problem. See, if अगर गलतियां होती हैं तो गलतियां करें, कोई दिक्कत नहीं है, लेकिन एग्जाम में ना करें. तो यहाँ पर आप गलती कर सकते हैं. ईच एंड एवरी मिस्टेक्स इज क्षम्य. यहाँ पर हर मिस्टेक्स आपकी क्षम्य है. आप गलतियां कर सकते हैं, और गलतियां अगर करेंगे ना, तभी तो आप समझेंगे कि आपने गलतियां कहाँ की. तो डू नॉट हेजिटेट टू कमिट द मिस्टेक्स. Try to attempt the question and tell me the answer. And when you will be doing some mistakes, definitely you will be learning a new concepts, and definitely that concept will be last longing in your mind. Okay, okay, so no problem. Try to understand. So there is a hot rolling process. So what is the meaning of hot rolling process? So in this hot rolling process, I have told you what are the things that I have told you in the hot rolling process. I have told you that surface quality is not good. Surface quality is not good, right? Surface quality is not good. So first, most important thing that you should always keep in mind, that in the hot rolling process, surface quality is less. If in the cold rolling process, surface quality is good. Ductility is less in this case, but ductility is more in that case. So just a minute. So now if you could understand from this, work hardening effect. See, in the hot rolling, what is the problem? That you are increasing the temperature. So temperature is increased. So when the temperature is increased, residual stress is decreased, residual stress is relieved. Fine. So if residual stress will be relieved, can I say that it is showing the work hardening effect? No, it is not showing the work hardening effect. Why? Because in earlier the residual stress was acting, and now the residual stress is relieved. So if you have not watched my yesterday's video, watch it. I have properly explained what is the meaning of strain hardening, work hardening, and how the residual stress is forming. So I would definitely tell you. So go and watch those things. Definitely your concepts will be very much good. Now see, surface finish is not good. Yes, it is true. It is true. So it is wrong. It is true. Heavy reduction in areas can be obtained. Very good. See, if in hot rolling temperature is increased, so temperature is increased, that material will have more flowability, that is ductility will be more. So if ductility will be more, can I say that ductility will be more, so heavy reduction can be possible? So it is also true. So what I can say here, that these two statement 2 and 3 are true and one is wrong. So where is it? Is it C? Yes, it is C. So are you understanding the concepts or not? समझ में आ रहा है या नहीं आ रहा है? चलिए इसको बताइए. Which of the following process would produce strongest component? Most important, produced strongest component. Always and always keep in mind in which process you are getting a very strong component. In which process you are getting a strong component? Is it a hot working process or a cold working process? So try to answer this question based upon that concept. Tell me the answer. Tell me the answer. Extrusion. Okay. See, if you could understand hot rolling, so it is a hot working process. Extrusion, it is also a hot working process. Cold rolling, this is a cold working process. And forging, this is also a hot working process. How can you forget these things? How can you forget these things, my dear friend? You should not. See, I have explained in this slide. That forging is a hot working process. Forging is a hot working process. Drawing is a hot working process. Rolling is generally a hot working process. Extrusion is a hot working process. So definitely, why hot working process? Because metal are subjected to more than recrystallization temperature. It is in the molten amount. So these all processes are the hot working process, and we have seen that in hot working process I will not get a good strength. In the cold working process only I will get a very good strength. Okay. Okay. So I was at this. So what I can say from here, that only and only this is the cold working process. And hence strength would be more in this case comparative to these cases. Fine. And hence my option is going to be C. Understood or not? Understood or not? Any doubt my dear friend? Any kind of doubts? कोई डाउट्स है क्या? कोई डाउट रहना भी नहीं चाहिए. कोई डाउट है क्या? चलिए, tell me the answer. Tell me the answer. In order to get a uniform thickness of the plate by rolling process, one provides. Tell me the answer. Tell me the answer. See, we have seen these things that earlier we were getting these kind of things. So thickness was not uniform in this case. So when you have applied a camber, so you are getting a uniform thickness material, and definitely in order to get a uniform thickness of the plate by the rolling process, definitely you will be applying a camber on the rolls. Clear? So I'm pretty much sure that you have really enjoyed this session and gained lots of knowledge. So before ending the session, I would like to start some of the mechanics of rolling. Okay, so like 5 to 10 minutes I would take more to to make you understand the mechanics of the rolling operations, what is happening in this rolling operation, and from tomorrow onwards we are going to solve in lots and lots of numerical based on the rolling operations. Okay, so now understand. So suppose this is your roller, so I'm not drawing the roller full, just a half roller is drawn. Okay. Yes, very good. Asais, kindly impact, Patil ji, Sohail, Rakib, everybody. Very good, very good. You have answered correct answer. Now focus here. I'm teaching you about the mechanics of rolling. So let us assume this is a roller. Okay, this is the first part of the roller, and this is the another roller. Right? This is the another roller. Okay, this is the another roller. Now assume just a minute. Okay, so assume this is your center of the roller. Fine, this is your center of the roller, and this is the center of the roller. This is the center of the roller. Now in this roller, what is happening? You are feeding a sheet, right? Suppose a sheet is fed like this and like this. Fine. Now the sheet is in contact from at this point. So let this point to be B, and after the rolling operations, you will be getting a finished product like this. So what we can say here, that at B, and let this point to be D. Okay, let this point to be D. Why I am writing these things? So see here, first of all, just a minute. See, at these two points, what I can say here, that there is a contact of my workpiece with the roller, right? Right or wrong? So again, if you would visualize here, so there is a contact here and there is a contact here at these 2 points in this roller. Okay, so see here, so let us assume this is my center, so this is A, fine, and this is A. So can I say that, let us assume this is B, So this is the radius. This is the radius of the roller. Fine. This is the radius of the roller. So let me write the terminologies here. So what is this? This is R. R is the radius of roller. Clear? Now, now understand. Now this is making, now let us assume, this point to be C, this point to be C, and this point to be D. What is these things? I'm explaining it. So this is the workpiece. This is the workpiece. So earlier this workpiece was having the dimension. What is the dimension? What is the dimension? It is h naught. It is h naught. Now this workpiece has a dimension. This workpiece, now this workpiece has a dimension of hf. Just a minute. Now this is having a dimension of hf. Fine. So see here what I can say here, that at B and D it is in the pure contact. So I can say that B and D, so BD is what? Contact length. Contact length. Now understand. Now understand. If you would draw an imaginary line, you would be able to understand that earlier you were having h naught, now you are having this hf. So this is the dimension, this is the dimension of hf, this is the dimension of hf. Now if I would be asking you what is this dimension, how much dimension is reduced, how much dimension is reduced, can I say that, can I say that it is delta h by 2, which is nothing but h naught minus of hf by 2. Now this roller is making some angle. Suppose this is the B and this is the D. Contact length is there. So from this contact point, of this workpiece and the roller, the angle is being made. That angle alpha, and alpha angle is known as angle of bite. Angle of bite. Okay. Now understand this. Now understand this concept. Now understand this concept. What is AD? What is AD? See here, what is AD? So AD is equal to AB is equal to radius of the roller. Right or wrong? It is a radius. Radius. Just a minute. It is a radius of the roller. Radius of the roller. Fine. So which is denoted by R? Which is denoted by R? Now I have found out CD to be delta H by 2. Delta H by 2. So can I say that what would be this distance? What will be this distance? AC. So can I say that AC would be R minus of delta H by 2? Delta H by 2. Let me remove it so that it looks cumbersome. Oh my god, just a minute. Let me draw it. Okay, so this is the roller. Fine. So now see here. So see here, this is delta H by 2. So delta H is nothing but HF minus of H naught by 2. Just a minute. H naught minus HF by 2. So these things are there. These things are there. Fine. Now, if I would be asking you, if I want to make a relation between the alpha, the R, what is the relation that I can make? Can I write R cos alpha? See here. see in this, can I write r cos alpha is equal to r minus of delta h by 2? See here, this is the r cos alpha, this is r cos alpha is equal to r minus delta h by 2, right or wrong? See, if you could take this small triangle, if you could take this small triangle, this is the small triangle, right? Let me take it, this is small triangle, this is the small triangle that you are taking. So in this small triangle, what you can understand, this is the r, this is r minus of delta h by 2, this is the alpha, this is a, this is b, this is c. So from this triangle arrangement, can you say that r cos alpha is equal to r minus delta h by 2? So you can write from here that r cos alpha is equal to r minus delta h by 2. Now from this you can write like that, delta h by 2 is equal to r minus of r cos alpha, which is nothing but r 1 minus of cos alpha, 1 minus of cos alpha. This is delta h by 2. So you can write delta h, there is a 2, so 2 will get here, so 2r 1 minus of cos alpha, and you will be getting delta h is equal to t into 1 minus of cos alpha. So this is the good relation that you have got between delta h, diameter of the roller, and the angle of bite, and the angle of bite. Fine, and the angle of bite. One more thing is there, contact length. I have talked about the contact length. I have talked about the contact length. What is the contact length, my dear friend? What is the contact length? I have told you that contact length is BD. That is, this is the BD, right? So this is the BD of contact length. So if this is R, and this is alpha, what is the BD? BD is the contact length. See, just a minute. So BD is the contact length. This is the contact length, right? This is the contact length, BD is the contact length. So can I say that my BD is nothing but it is R alpha, so my contact length BD will be R alpha. So remember BD is R alpha delta H. Now you may be understanding what is this delta H. So delta is the change in the thickness, but my dear friend, there is a term that is known as maximum possible draft. I would explain you, there is a 2 times rolling can be happening, 3 times, how many times rolling can be happening. So there is these concepts are there. I would be going into these things in a very great details in tomorrow's session. For this session I would like to end this session on this note by giving you these two beautiful important formulas are there, very important formulas are there from gate point of view. From a gate point of view, these two formulas are very much important, very much important. Okay, so you can solve the questions. Okay, so before ending the session, I would like to ask you one question. Okay, so just before that, I would check a comment box if you have any problem. Sir, machine tools kab hoga? Okay, see, I have explained it. Machine tools, my dear friend, machine so there are machine tools. In machine tools, like some of the things I would be explaining, so definitely I would be taking those new classes would be there, like for that in session I would be taking you about advanced machining processes, non-traditional machining processes I would be taking, and everything I would be taking. I would make a separate class for that. But for machining, for like metal cutting, I have completed the metal cutting, my dear friend. You can check these metal cutting from there. Angle is equal to arc by radius. Very good, Prashant, very good. These things are very basic. Very good, Prashant, very good. Basics is very much important, and you Prashant, you will be agreeing with me that basic is very much important. These throughout these derivation, everything was basic. This is the trigonometry, these are geometry. So basic thing is very much important. If you have a basic understanding, my dear friend, you will be able to solve everything. Thank you so much, Asis. That is what exactly I try my level best. I have explained the metal cutting. See, you can search. You can search. I've told you. See, you can search manufacturing gate 2021. For this, you will be getting the two for search my name. If it is not you are not getting this, search my name, and you will be getting the two playlist. So there is a two playlist. So playlist one would be there, playlist one would be there, and playlist two would be there. So in the one first playlist, there would be a 12 videos of metal cutting, and the second playlist would be there. In that, I'm continuing. So currently you will find 26 or 27 videos are there, right? So 27 videos is there. So in this currently, casting plus welding, and now I'm teaching the forming. So forming is also going to be there. So you can check these things. This is in lead channel. I have taught in lead channel, and this is in the uh, let's crack GATE and ESE. So you can definitely check those things. Now, before that, tell me the answer. Suppose there is a rolling operation. So there is a rolling operations like this. So there is a rolling operations like this. Okay. So in that rolling operation, suppose you are feeding the the part like this. Just a minute. Suppose the height of the sheet was 16 mm. Fine. Now it has been rolled. Now after the rolling, this is the height. Suppose that 10 mm is there, right? Now if I would be asking you, find the angle of bite. Find the angle of bite. Can you tell me the answer? What would be the angle of bite? What would be the angle of bite? This is the alpha. Can you tell me the answer? What would be the angle of bite? Suppose the diameter of the roller is 400 mm. Okay, so this is the diameter of roller. Try to find the angle of bite and tell me the answer. How you can find the angle of bite? Tell me the answer. Just apply this formula. Delta H is equal to D into 1 minus of cos alpha. D into 1 minus of cos alpha. Okay, try to find the answers. Tell me the answer. What is the answer? Use this formula. Okay, use this formula. Tell me the answer. Okay, 9.93. What about others? Asis has told the answer 9.93. What about the others? You're not getting the answer? You're not getting the answers? You're not getting the answers? Tell me. What about everyone? Okay, so I will be waiting for about like 10 seconds, 10 to 20 seconds, and then I will be explaining these questions. I would give you time so that you can attempt this question. Okay. See, simple question is there. You just have to apply this formula. Delta H is equal to D into 1 minus of cos alpha. So delta H is equal to D into 1 minus of cos alpha. Okay. So from this, what is the delta H? What is the delta H? Earlier it was H naught. So H naught is this. This is HF. So you can find delta H is nothing but H naught minus of HF by 2, which is what this is. This is, just a minute, this is delta H. So you can find it here, that is 16 mm minus of 10 mm. This is delta H. Delta H would be what? 6 mm. Substitute the 6 mm here. What is the diameter? You know the diameter, 400 mm. So now each and everything is easy for you. Each and everything is easy for you. You know the diameter, you know the delta H, you know the delta H. Now you can very easily find the alpha. Find the alpha. So what is this alpha? This alpha would be, that would be coming around 9.826 degree. Now tomorrow, in tomorrow's session, I would be deriving these two more formula. Let us see, this formula is there. One more formula is there, that is tan alpha is equal to root over of delta H by R. So I will be explaining this formula in tomorrow's session. And from this, what is this tan alpha? This is also known as like mu, right? Coefficient of friction. So the relation between coefficient of friction, these things I will be teaching you in the tomorrow's session, my dear friend. And if you have any kind of doubt in this session, feel free to ask with me. Feel free to ask with me, and I would try my level best to clear your doubts. Very good, Prashant. That is correct. That is correct. That is the method. That is the correct method. Okay. If you have any kind of doubt, you can ask with me. You can ask with me. And if you have understood the concepts very much clearly, if you have really enjoyed my session, do like this session, as well as share this video in your friend circle, in your peers, so that they will also be getting benefited. And if you are purchasing a plus subscription, use my code SIRVK, 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 to get a 10% off, as well as I will provide a personal mentorship to you also. See, how the forces are going to be opposite. See, Ashish, see. The two roles are there. So first role is here, the second role is here. So when you are passing the material from here, so first role is moving in opposite direction, and second role is moving in opposite direction, right? So with the respect to both the roles, if you are checking about the directions from both the roles, so with respect to each and every roles, the direction of rotation would be different, and hence you will be getting a different forces in different directions. Okay. Okay. Not understood? Still not convinced? Okay, no problem. So like, I would make you explain these things. Don't worry, don't worry. As the classes will go on, ठीक है, जितना ज़्यादा हम लोग क्लासेस करेंगे, so definitely आपको forces समझ में आएंगी. So tomorrow I would be doing like power calculations, force calculations, mechanics. Definitely I would be telling about the mechanics. So in that mechanics, definitely your understanding would be more enhanced. Okay, so if you are not understood in this class, definitely you will be understanding in the next class also, because in next class I would be explaining you these things. Fine. Power calculations, everything. Thank you everyone, thank you. So I'm just ending this session. Thank you everyone for being so much patiently listening me in this late night. So thank you so much for being very patient and listening to it. So thank you so much for your active participation. I'm ending this session. Okay. So I assume that you don't have any doubt. Yes, yes, Prashantji. Yes, that is exactly I'm going to tell you. Mechanics of rolling. Fine. I've just started the concept. Thank you so much for being lovely listener. Thank you so much. I'm ending the session.